Fourth assignment of alkyl and aryl halides. First is nomenclature. I'll explain the structure. First example, CH3 twice CH. Then CHCl, CH3. Now, this will be the directional counting. IUPAC name will be 2-chloro-3-methyl-butane, and this is a secondary alkyl halide. Secondary alkyl halide. Next, CH3CH double bond. CHCl, CH3. In this case, double bond is given more preference than halogen. So this is the direction of counting. This will be 4-chloro-pent-2-ene. 4-chloro-pent-2-ene, and this is secondary allylic halide. Secondary allylic halide. Third is a typical one. Somewhere in the middle, you are given C6H4. C6H4 is a part of benzene ring. Then at meta position is CH2Cl. And out here it is CH2CH, CH2C, CH3 thrice. Now, try to understand in one go. It's a difficult one and it will take time. First, we'll name this part. We'll count in this direction, and this part will be 2,2-dimethyl propane. 2,2-dimethyl propane. This is carbon number 1. So on carbon number 1 of propane, this is attached. Now I'll name this one. If CH2Cl is not present, then first carbon is bonded to phenyl group. I'm writing phenyl. In case we count carbon atoms of the aromatic ring, this will be 1 dash, 2 dash, 3 dash, 4 dash. At carbon number 3 dash, CH2Cl is attached. Let us say it is CH3. If it is CH3, then I'll say this is 1 dash methyl phenyl. 1 dash methyl phenyl. So I can say on first carbon of propane, 3 dash. 3 dash methyl phenyl is attached. Right? Now, this methyl is attached to chlorine. It means it is not methyl, it is chloromethyl group. So this is chloromethyl. Now understand the IUPAC name. Propane. This is propane. Carries 2,2-dimethyl. These are 2 methyls. On carbon number 1, phenyl is present. At carbon number 3 dash of phenyl, chloromethyl group is attached. So this is the complete IUPAC name, and this is a primary benzylic halide. Primary benzylic halide. Now coming to fill in the blanks. First is pentene plus pentene with HBr gives A. I'm directly writing answers because I want to save time. So A will be 3-bromopentane. This addition will take place according to Markovnikov's rule. This product A, that is 3-bromopentane, is reacted with sodium iodide NaI. Sodium iodide in the presence of acetone. This is Finkelstein's reaction in which bromine will be replaced by iodine. So B is 3-iodopentane. Now this 3-iodopentane is reacted with sodium acetate. This is again NSR, sodium acetate, sodium or silver salt of carboxylic acid reacts with alkyl halide to give an ester. Now let me explain. This is CH3COO-Na. NAI will be eliminated. This carbon will form a bond with this oxygen atom. It means the product will be CH3COO, this part. Now this carbon will form a bond here. This is attached to, you can see, this is a straight chain of 5 carbon atoms. Bond is formed through third carbon atom. So this is the ester, structure of the ester formed. Second sequence. Very easy. A plus B gives benzene diazonium chloride and reacts with C to give fluorobenzene. This is a Bar-Schimann reaction. Well, directly write answers. A will be aniline. B will be HNO2, HCl, 0 to 5 degrees centigrade. Everything, every temperature pressure has to be specified. In place of HNO2, you can also write NaNO2. That is your choice. In situ preparation of HNO2. And C will be HbF4. These are answers of A, B, and C. Next, third sequence. At the end, we are given 2-methylpentane nitrile. This is 2-methylpentane nitrile. This is formed by the reaction of E with KCN. This CN comes from here. It means halogen should be present here. And what is the halogen present? If you look at the arrow, previous arrow, it is PCl5. PCl5 means chlorine is present here. What reacts with PCl5 to give chloroalkane? It's an alcohol. It means B should be an alcohol with OH group at the same carbon atom. And one thing more, look, this is a straight chain of 5 carbon atoms. This is a straight chain. So this is 2-pentanol. 2-pentanol is formed by the reaction between C and B and C. And this B is formed by the reaction of A with HBr peroxide. It means this is anti-Markovnikov addition of HBr. And we want bromine on second carbon so that bromine can be replaced by OH group. For that, A should be 2-pentene. Think in terms of anti-Markovnikov addition. 2-pentene with HBr, OP will give 2-bromo. If you take 1 pentene, product will be 1-bromopentane, which we do not want. This will be 2-bromopentane. And this is aqueous NaOH. That is, nucleophilic substitution reaction takes place. Fourth sequence. At the end, we are given C6H5, CH2, NHCH3. For the preparation of this compound, we are given benzyl iodide and D. It means this part comes from benzyl iodide. This remaining part comes from, think of NSR, comes from CH3NH2. Can anyone tell me name of this reaction? You have to remember names of these reactions. Please devote time. This is Hoffman's ammonolysis. Now this benzyl iodide is formed by the reaction between B and C. And this B is formed by the reaction of A with HCl zinc chloride. Okay, tell me HCl zinc chloride. Tell me name of this reaction.
Sir, Lucas reagent reaction.
This is Lucas reagent, but in terms of preparation, we call it Gross method. You remember Gross method? And in Gross method, product is chloroalkane and reactant is an alcohol. And this chloro will be replaced by iodo. It means alcohol is benzyl alcohol. With Gross method, it will give benzyl chloride. And tell me what is the name of this reaction? Come on. Fincke-Stase reaction. AI acetone. Children, believe me, you'll be lost in a sea of reactions. There'll be so many reactions coming up in remaining 3 chapters of organic chemistry. Devote time. If you solve assignments yourself, you'll learn these equations. It will become very easy for you. Anyways, choice is yours. Next question is explain why. These are both AB type questions. It means answers will find in your notes. Coming to what happens when toluene is reacted with chlorine in the presence of sunlight. I'm only writing the product. In words, you'll write when so and so is done, side chain chlorination takes place to give benzyl chloride. Side chain chlorination, right? Second, silver acetate is treated with bromine in the presence of carbon tetrachloride. Silver acetate, CH3COOAG, with bromine in the presence of triCCl4. Okay, product obtained will be CH3Br, carbon dioxide plus AgBr. Okay, can you tell me name of this reaction?
Sir, Brodine-Hunsdiker reaction.
Yes, we'll say when so and so is done, Hunsdiker-Borodine reaction takes place to give bromomethane. This is a step down reaction. Distinguish between. See, in distinguish between questions, maybe I explained earlier also, I'll explain again. I'll tell you what you have to do. In distinguish, you'll be given 2 compounds. You have to distinguish between them. It's always on the basis of a chemical reaction, not on the basis of any physical property. Both the given compounds should be treated in a similar manner with whatever chemicals you want to use. If I react one compound with chlorine, I'll react the other compound also with chlorine. If I heat one compound, first compound, I heat the second compound as well. Parallel treatment. This is called parallel treatment. Ultimately, what should happen? There are 4 possibilities. Listen very carefully. Ultimately, there should be a colored product formed in one case, not in the other. Second possibility, if colored product is formed in both the cases, then color of products should be different. Third possibility, there may be evolution of a gas in the form of bubbles in one case, not in the other. This evolution of gas in the form of bubbles is called effervescence. Like when you open the bottle of a soft drink, that is effervescence. And fourth possibility is there is a product of peculiar smell formed in one case, but not in the other. Peculiar smell may be formation of an ester, which is a sweet smelling compound, right? So this type of change should take place. So first pair is propane and propene. One I'll explain in detail, then will be fast. Propane and propene. We treat both the compounds with bromine water. In the second case, reaction will take place, we'll get 1,2-dibromopropane, and in this case, no reaction will take place. Now let me tell you what you have to do. First of all, you have to write a balanced chemical equation. I've written balanced equation in one. There's no reaction in the second case. But in the second case, on the product side, I will not write no reaction. Now listen to the language which I'm using. So when treated with bromine water, propene decolorizes it, propane does not. Right? Propene decolorizes it, propane does not. So on the product side, in case of propane, you will write no decolorization. In this case, you'll write gets decolorized. That's what is the presentation. Second pair, bromoethane and chloroethane. See, if you react both these compounds with AgNO2, that is one of the NSR, react both of them with AgNO2. In both the cases, we'll get nitroethane and nitroethane, but the second product will be different. In this case, it will be AgBr formed. AgBr will be light yellow precipitates. In the second case, white precipitates of AgCl will be produced, right? So ultimately, what is the difference? Color of products is different. That's how we can distinguish. Now, next question. How will you convert ethanol into 1-butene? Now, it is specified in 2 steps. It means this conversion has to be carried out in 2 steps, neither less than 2 steps nor more than 2 steps. Less than 2 steps will be considered wrong. More than 2 steps will also be considered wrong. So what are these 2 steps? Convert this into alkyl halide. You have studied 3 different methods to convert alcohol into alkyl halide. Use any one of them. Let us say PCl5. Then use one of the NSRs, which will give a higher alkyne. That was the reaction with sodium alkyanide. Sodium ethionide. Next, propene into 1-propanol. We want a group on first carbon atom. Anti-Markovnikov is only for HBr, not any other halogen. Use anti-Markovnikov rule, HBr in the presence of organic peroxide. Then replace bromine by OH group, react with aqueous NaOH. Right? You get the final product. 7th question. Arrange bromomethane, bromoform, chloromethane, and dibromomethane in the increasing boiling points. See, all of them contain 1 carbon atom. We have to arrange in increasing boiling point. This question is based on molecular weight. Higher the molecular weight, higher will be the boiling point. So least will be this, then this, and highest boiling point, sorry, no. This will be 3, and highest boiling point will be bromoform on the basis of molecular weight. Arrange this in the increasing reactivity with KCN by SN2 mechanism. In SN2 mechanism, if you remember, I told you, we have to arrange in increasing reactivity. In SN2 mechanism, which is based on steric hindrance, maximum reactivity will be primary alkyl halide, least will be tertiary alkyl halide. Now, if you look at the structures of these 3 compounds given, they are, one is primary, the other is secondary, the other is third is tertiary. So you arrange them in this order, that will be your answer. Right? Sure.